Guys, in the last part of this chapter, we're going to talk about torque and simple machines. Guys, you probably are familiar with the word torque. When we talk about trucks and stuff, we talk about torque. Anyway, so when we have an object moving in space, it can move two ways. It can move what is called translationally. Physically, the body was over here and then ended up over here. So the center of mass moved in a parabola, practically in the parabola, because this was free fall. But at the same time, the diver's body was rotating relative to the center of mass. So if we were to imagine a little axis going through this point, her body is rotating relative to this axis. So rotational motion is when something is spinning. All right, why does an object move? Let's say I have a stationary object right here. In order for it to move from one place to another, I need to apply force. So if I apply force, I can physically move it from this place to this place, and there will be displacement. I will do some work, right? Because the force is applied. As a result of this force, there is displacement, so this force times displacement gives us work. And then the unit for work is joule, but it's actually just Newton times meter, so N times M. Torque will also be measured in Newton times meter, and you will see why. So let's consider this. If I have the same object, but now it cannot move from one place to another, but it can rotate relative to this little point. So think, if we pinned this, and it can be moving relative to this, so it can rotate counterclockwise or clockwise. In order for it to rotate, obviously, I also need to apply force. So if I apply this force, it will rotate in this direction, clockwise, because I'm applying force clockwise. Think, what if I applied this force somewhere other than at the very end? Think about opening the door. If you are pushing the door and you push at the end of it, it's easier versus if you try to push it in the middle. So if I had the force applied over here, I would have to apply more force to achieve the same rotation. There is a reason for it. Torque produced by the force depends on the force and on one more thing. Well, first of all, what is torque? If we apply force and it rotates the object relative to the axis of rotation, then we can talk about torque. So here's what you need to write down. Torque is the ability of a force to rotate an object around some axis. So basically, over here, if you think of the nut on the bolt, the axis of rotation of the nut is going through the center, so that's the bolt. You can think of the bolt as the axis of rotation. In that example for the diver, that imaginary line that would go through the center of mass, that would be the axis of rotation of the diver. So, force times LA, so in other words, we have this FLA, will give us torque. And think, force is newtons, lever arm is measured in meters, because that's the distance, that's how far away from the axis you applied the force. All right, so torque equals FLA, where LA is lever arm. And what is lever arm? Lever arm, expressed in words, is the shortest distance from the axis of rotation to the line of the force. Now, you don't have to write this down, because as we go to the next slide, I think this will stick right away. So let's say we have three objects here. They're the same. They all have the axis of rotation. Let's say I apply force over here. This force times lever arm will give me the torque. Now, what is the lever arm? That's the distance between the axis of rotation and the line of the force, right here. Mind you, the shortest distance. Because think, I could have drawn a line from here to here, it would be longer. And I'm thinking of the shortest distance. Here's another example. If I apply the same force, but closer to the axis of rotation, what do you think? Will that be less torque or more torque? Again, think about opening the door, pushing at the very end of the door or in the middle. The result here would be better because you have a longer lever arm versus here where the lever arm is shorter. In the third example, I'm going to apply the same force, well, not the same, a little smaller, you'll see, but I will apply the force at an angle. So here we go. Now, what's the lever arm here? Is it this between the axis of rotation and where the force is applied? Nope. The shortest distance between the axis of rotation and the line of the force. Here is the line of the force. And what is the shortest distance between some point and a line? It's the perpendicular. So if you are to draw a perpendicular onto the line of the force, you will get this lever arm. The length of this perpendicular right here, that's your LA, that's your lever arm. So let's look at some examples. Let's say I have this wrench, and this is the axis of rotation of the nut, and this is where I am applying the force. Now, what's the distance between this axis of rotation and the force? You are not thinking of the distance between the axis and where the force is applied. It's the distance between the line of the force and the axis of rotation. So here we go. This d sine of theta, and why is it d sine of theta? That's the d right here. That's the hypotenuse. That's the length of my tool. The longer the tool, the better, right? I could have held on to the same tool over here, but it would be harder for me to rotate the nut. So this d times sine of theta. Why is it sine? Because it's opposite, right? This d sine of theta would be my lever arm. So in this example, I would take the force multiplied by d times sine of theta, and that would give me the torque. Newtons times meters. That's the unit for torque. But it's not always d sine of theta, so do not memorize it that way. What you need to associate torque with is FLA, force times lever arm. Because here's another example. The tendon exerts this force, and it lifts the heel, and we are given the size of the heel right here from the axis of rotation, because this is relative to what we are talking about, the rotation, because it can go down and up, down and up. This is where the tendon is attached, and so therefore that's where the force is applied. What's the lever arm in this case? This is the axis of rotation. This is the line of the force. This right here is the lever arm. And we know this angle. So if I know this, and I need to find that, I would use cosine in this case. Now if you look at the work over here, I took 720, that's my force, applied by the tendon, and 3.6 times 10 to the negative 2, so it's 3.6 centimeters, multiplied by cosine of 55. But for some reason, in my answer, I'm saying that this is negative 15 newtons times meters. There is a reason for that. It was decided that clockwise torque is negative. Counterclockwise torque is positive. So when you're thinking whether the torque is positive or negative, picture the force that is applied to an object. Which way will it rotate the object? Counterclockwise or clockwise? So if we're talking about lifting the heel is going clockwise. That's why this torque right here produced by this tendon is going to be negative. What about here? If we have more than one force applied, so this is some kind of disc. You can think about this as a steering wheel, for example, and you have two hands, and your hands are applying forces to the wheel. 15 newtons going this way. Will it produce positive torque or negative torque? It would rotate it clockwise, right? So it would be a negative torque. And this force right here, it's also rotating clockwise, so this will also be negative. Now in this case, what's the lever arm here? That would be the radius, right? The radius of this circle right here, that's your lever arm. That is the shortest distance. That's the line of the force, that's the axis of rotation. This is the lever arm. And then from here to here, this would be the lever arm because this is the line of the force, and it's also producing negative torque. So if we were to find the net torque, we would find each one of those and then just add them together. That's it for the torque. So what you need to do next is just watch a quick video about simple machines. And you have studied those in middle school. It's about the screw, the pulley, and the lever actually, yeah, and the inclined plane. So that shouldn't take you long. Thanks for watching. See you tomorrow in class.